All right, ninth graders, we are going to talk about function operations. So we've talked a lot about functions. Mr. Bodley did a review on what functions are. Yesterday, we did work with input-output tables. And today, I'm going to give you functions, and your job is going to be adding them, subtracting them, multiplying them, etc. So I want to have you, first of all, on your notes today, title it function operations, and then I'm going to put down two functions for you to write down. So the first one is called f of x. So we've got f of x equals 5x minus 12. And then the second function you're going to write down, g of x equals 3x. All right, so we've got these two functions, and you might be wondering right now, why is one of them labeled f of x and the other one's g of x? That's just giving it two different names so that we know that they are two different functions. So f of x, typically people call that function of x. These are all functions, but once you've used f of x for 5x minus 12, if you have a new function that's not 5x minus 12, you need to have a new name, which is why we called it g of x. It's just a different letter. So if we had another function, we could call it h of x or j of x or k of x, any of those things to show that it's different. All right, so after you wrote down your two functions, I want you to write down example 1. So for example 1, we are going to do a mathematical operation with f of x and g of x. So I am going to write down f of x plus g of x. Now, this is actually going to be really simple because wherever there's an f of x, I'm just going to replace it with 5x minus 12. So underneath this f of x, I'm going to replace that thing with what f of x already is, 5x minus 12. And sometimes you'll even see people put parentheses right there. Totally fine. That's not a bad habit to get into. Then you're going to add on, and then we're going to see what g of x equals. So over here, instead of g of x, I'm going to put 3x there. So you're adding on 3x. Now, you'll see that there are parentheses on both of these. There's nothing to distribute in front of them. There's not like a 2 up here, so I don't have to distribute a 2 in. There's really nothing but a 1 in front of both of them. Now, if you did 1 times 3x, it's still 3x. So this, the parentheses can be dropped. It can just be 5x minus 12 plus 3x. Now, this phrase right here is not a simplified expression because I've got a couple things that are alike. 5x and 3x both have x's on them. So 5x's plus 3x gives me 8x, and then we still have a minus 12 there. Now there's nothing else that I can do to simplify this. So here's my simplified answer, 8x minus 12. That was example 1. So in order to add them together, I just add what the two things are together. All right, now I'm going to show you another example. The second example I'm going to do on this side, we're going to label it example 2. So kind of box off example 1. Okay, on your paper, make some space for example 2. And example 2 is going to be g of x minus f of x. It's really important that you write these down in order. It has to be g of x first minus f of x second. So now let's start putting the things in where they belong. Instead of g of x, I'm going to put in 3x. And then when I subtract off f of x, I'm subtracting that 5x minus 12. Now, I want you to remember something I did last time. Last time I put parentheses on it. I'm going to run into a huge mistake right now if I don't put parentheses here. Because if I leave it like this, then I'm just going to do 3x minus 5x, and then there's just a minus 12 on the end. However, what I really should have is the 5x minus 12 is in parentheses. And the 3x could be in parentheses, but it's all alone. It's already just fine all its own. But here's why it's so important that the 5x minus 12 is in parentheses. This is not a positive 1 in front of it. That's a negative 1. And so when you would distribute that, it would become 3x still in front. And now I'm going to distribute that negative 1 to everything in the parentheses. So it's going to be 3x minus 5x, because negative 1 times 5x is negative 5x. And then negative 1 times negative 12 is plus 12. So 9th graders, it was so important for me to put those parentheses around f of x. Okay, so now I've got 3x's minus 5x, and when I subtract 3x minus 5x, I get negative 2x. And then the plus 12 is just on the end there. That's my final answer. Negative 2x plus 12. Okay, so again, the big thing you had to remember here was when you put it in, it had to go in order, and you had to put parentheses around the thing that you're subtracting. That way, we were able to get the positive 12 after we distributed. Okay, let's do another example. Just like sliding back and forth. We're gonna do the next one, example 3, and it's going to be a multiplication problem. So what you're gonna see, slide this over. For example 3, is 2 times f of x. All right, I'm multiplying 2 times f of x. I'm going to try what I did last time. I'm going to take everything that's a function, and I'm going to put the function in its place. So I still have the 2 in front, but then I'm timesing by the f of x, which was 5x minus 12. Now I'm going to run into a problem here if I don't do that thing that I starred over there 3 times. Because right now it just looks like I'm multiplying 2 times 5x, but that's not true. This 5x minus 12 all goes together because it's all f of x. So you need to double the entire f of x. So that means I need to distribute this 2 to everything that was f of x. So 2 times 5x is 10x, and then 2 times negative 12, negative 24. That's my final answer. So this one was a little bit more intense because we had to distribute to both things. If I had said 2 times g of x, then I would really just be doing 2 times 3x, which would be 6x. So this one, we had to distribute it to all the pieces of f of x. Okay, one last example, the best one of all. We're going to call this example 4, and I'll put it over here. So for example 4, we are going to use a little bit of what we learned during the input-output stuff. So I want you to write down example 4. And we are going to write f of 0 plus g of negative 5. So f of 0 plus g of negative 5. Oh my goodness, I got rid of the x's. Well, if I got rid of the x's, that means new things have to go in the place of x on the original equation. So f of 0, wherever there's an x up here in the f equation, I need to put zeros in its place. So let me see what that looks like. I'm going to draw an arrow over here, and f of 0, instead of 5 times x minus 12, that is going to be 5. But instead of times x, I'm multiplying by 0. And then I have my minus 12. Okay, so 5 times 0 is 0, minus 12 is negative 12. All right, so there's my f of 0, is negative 12. Okay, but that's not all I needed here. I needed g of negative 5. So I take this negative 5 and I replace it into the g equation where there's an x. So instead of 3 times x, it's going to be 3 times negative 5. All right, you should know that in your head, or you can know it with a calculator. I don't really care how you figured it out, but 3 times negative 5 is negative 15. All right, we have 2 parts of our answer, but here's what we wanted to know. F of 0 plus g of negative 5. So if f of 0 was negative 12 and g of negative 5 was negative 15, I need to add those together. So negative 12 plus negative 15. These are both negative, so I know that 12 plus 15 alone would be 27, but since they're both negative, it's negative 27. All right, those were the 4 examples I wanted to go over with you. Hopefully you wrote yourself some good notes because you're gonna have 4 problems just like it for tonight's homework. All right, see you later, 9th graders.